In this video, we will explore curve sketching with Simplexety. This program can also be accessed in SimplexNumerica. First, open a new page in SimplexNumerica. Then, we go to the ribbon bar labeled Interface. Next, we open Simplexety. We do not require a return value. Here, we call up an example function. We recognize this function as a standard polynomial. Let's select the second tab to display the first derivative. The next tab shows the second derivative. The third tab shows the 0 points within the range of -10 to +10. Now let's take a look at the graph. This is the type of graph we remember from school. Well, it looks similar to the one we saw there, at least. From the Mathematics menu, select Curve Sketching. The result is displayed on a local web page. This shows the complete curve sketching. We can now scroll down through the document. We can now see the derivative of the function. Next, we see the local extremes, the minimum and maximum. Next, we see the inflection points and the turning points. We also see the condition for this, as well as the equation of the tangent at the turning point. We can also see the curvature behavior with the left-right or right-left transition. Finally, we look at the 0 points of the function. This document was automatically generated by Simplexety. We can now also import these results into SimplexNumerica evaluation page. To do this, we simply create an HTML page and call up a chart. We then open the web page in SimplexNumerica and locate the file that we have just created. We are no longer in the Microsoft Edge or Google Chrome web browser. The web page is now displayed within SimplexNumerica. We can also display curve sketching in a standard SimplexNumerica evaluation window. To do this, we need to make the size of the page a little bit wider. However, we will not do that now. Now let's go through the same steps again, but this time using Simplexety. First, we open the app and load a function directly. Class Test1 Task 1F is displayed again. This time, the fourth part is negative, revealing the descending function. The special thing about this is that the vertex only touches the x-axis. This is not usually recognized as a 0 point. However, for curve sketching, it must be considered a 0 point. This is very important, and we will now demonstrate it. As you can see here, the 0 has been recognized at the inflection point. This means that the inflection point is also a 0 point. Here are all the zeros listed in order once again. Next, let's load another function, task number 2 from the class test. Here, constants can be specified directly in the program. In Simplexety, enter them separated by semicolons from A to D, then press enter and call up the graph again. You will see that the function has only one 0 point. Of course, you could also find this out by sketching the curve. That is the function again. These are the derivatives of the functions. These are the local extrema, the minimum and the maximum. These are the 0 points of the function. There is nothing more to say about this. Inflection points are not relevant here, so that is essentially the outcome. If you compare it now, you can see that the 0 point lies between -1.2 and -1.4. Finally, let's take another look at the initial function and the polynomial curve. That's it. Thank you very much. Bye.